Hi, welcome you all for the serial communication protocol series. In this video, we are going to see about I2C communication. I2C communication, before I2C communication, we have discussed about UART and SPY. So topic that we are going to cover in this video is how will be the start and stop conditions, how the addressing will be done, NAC and ACK, clock stitchings, along with the we will see what is basics of I2C and how will be the data frames. So I2C stands for inter-integrated circuit. Okay, it is nothing but inter-integrated circuit, and it is also called a synchronized one. Already we have seen UART as well as SPY. In that, UART is a asynchronous one and the SPY is a synchronous communication protocol, because in UART we don't have clock signal, so it is called asynchronous one, and SPY is a synchronized communication protocol. Similar like SPY, I2C is also synchronous serial communication, and it uses only 2 wires. SPY is using 4 wires. UART is using 2 wires, TX and RX. SPY is using 4 wire, meso, MOSI, clock and chip select. I2C uses only 2 wires. Since it is a synchronized protocol, obviously one wire will be a clock and another wire will be used to transmit the data. Okay, so I2C is 2 wire system. It supports communication between multiple devices. As like SPY, it is also support for communication between the multiple devices, and basically it follows the master-slave architecture. I mean, one device will act as master and multiple sensors will act as slave. By using the master-slave concept, it will communicate with each other. So what are the main features? It is a two-way communication. It supports multi-master and multi-slave. Multiple master can be present in my module. At a time, one will act as a master. As well as it is address-based communication. In SPI, we use control select line to select to which slave it wants to communicate. Whereas in I2C, by using the address, we are going to define to which sensor my master is going to communicate. So hence we can say it is an intelligent communication protocol when compared to all other. Then also it supports for bidirectional data transfer, but simultaneously it can't transmit, so it is off duplex. Cost wise it is low and it is simple to integrate. So advantages are it requires only 2 wire, one is clock and data. Since it come up with a 2 wire system, PCB complexity is low compared to SPY. You can easily connect many devices. Then it supports multi-master and multi-slave method. If I am going for short distance communication, then it is a good choice to choose I2C. Then application. Application mainly it is used in temperature sensors, EEPROMs, RTC and OLED displays. LCD. In some modules you can see instead of ground, VCC and pin, along with that we will have clock and data line. So those things comes into the I2C peripherals. Sorry, I2C based sensors. Then I2C bus. Already I have mentioned 2 lines will be there. One is clock and another one is data. In I2C, how they are saying data is called a serial data line or SDA. Clock is called a serial clock line or SCL. Okay, data line is used to transfer the data between the device. Clock is nothing but it carries the clock signal, but it is generated by SPY. If we are going for master-slave architecture, master is the one who will be responsible for generating the clock, as well as master is the one who will initiate the transaction. Okay. Then additional points are both lines are bidirectional only, and it uses a pull-up resistor, then open drain and open collector configurations. Then I2C architecture, I said it has master and slave. Master is the one which initiate the communication, as well as it is the one which generate the clock. Slave device will respond to the master request. Okay. Multi-master support is nothing but I am going to have more than one master in the same bus. Okay, then it is called as multi-master. So you can ask, you are having 2 master like master 1 and master 2. Both my masters are simultaneously wanted to communicate with my sensor 1. I mean, both my master 1 is trying to communicate with slave 1. Master 2 is also trying to communicate with slave 1. Means at the time there must be some collision, right? That collisions will be avoided by using the arbitration mechanism. We will see arbitration mechanism in the upcoming videos. Then I2C addressing. While we are discussing about introduction of I2C, there itself we have see a point called it is address based communication protocol. So each slave has unique address. I am having slave 1, slave 2. While coming itself, it will come up with some unique address like it is 49 and this is 48. Its address will be defined when it is manufactured. Okay, so address will be 7-bit address or 10-bit address. Mostly come up with the 7-bit address. For an example, here I have taken my slave address is 0x49. Its binary value is this. Okay, so along with the 7-bit, the last bit is the one which will determine by using the address I am going to write to the device or read from the device. Okay, so 7-bit is the address. If my 8th bit, I mean last LSB is kept as 0 means it is act as write address. If it is 1 means it is act as read address. Is it clear? By using the 7-bit address, by simply changing the last bit, I mean keeping it as 0 or 1, I can use that address as write address and read address to that sensor. Okay, so 0 is for write operation and 1 is for read operation. Is it clear how the write address and read address is found? Next one is I2C communication process. Now my master is sending. Okay, my master is sending some information to my slave. How this communication is happening? Similar like you are, here also we have here start bit and stop bit. Before getting into the frame format, we can categorize. First we are going to do write operation and then we can see read operation. Okay, in write operation, first bit is start bit and last bit is stop bit. That we know because in UART also it is similar like this. After the start bit, this message, I mean this frame is sent from my master. Okay, after the start bit, I have to give the 7-bit address like for an example, I am having slave 1 and a slave 2 and a slave 3. This address is 49. This address is 49 and my slave 2 address is 48 means to which slave my master wanted to communicate. For an example, my master want to write to my slave 1 means it must carry the address of slave 1. Then I am going to do write operation. Write operation means this bit has to be set as 0. So this is set as 0. Then after this, it will have a acknowledgement. This acknowledgement will be sent by my slave to the master. Okay, after my master receives the acknowledgement like so you search for me and I am available here, hence it gives the acknowledgement. After the acknowledgement is got from slave 1, it will send the data which has to be written in the, I mean which is supposed to write in my slave 1. Okay, so after the acknowledgement received, it will send the 8-bit data to my slave 1. Okay, for an example, I want to send 16-bit data means first I will send 8-bit data, then my slave will give the acknowledgement. After the acknowledgement received, again I will send the 8-bit data. So till I have sent the 16-bit data, for every 8-bit I will get the acknowledgement. After I have transmitted all the data to my slave 1, I will send a stop bit. Okay, this is how the frame format of write operation will be that. Then we can see the read operation. Read operation of I2C will be similar like write operation. It has a start bit and a stop bit, and after the start bit it will send the slave address, and in this bit we will represent it is going to do read operation or write operation. Here we are going to do read operation, hence this particular bit is kept as 1. After this acknowledgement is sent from my slave 1. Okay, this acknowledgement is sent from my slave 1. After the acknowledgement is received, this bit is sent from my slave. I am getting the data. Okay, after I am getting the data, acknowledgement will be given by the master. This data is sent from slave. Okay, so I received, then acknowledgement will be given from the master. If suppose I am requiring 16 bit from the slave, means first 8 bit I will give the acknowledgement. After, last transmission, my master won't acknowledge it. Okay, 16 bit means first 8 bit my master will give acknowledgement. Next 8 bit master will not give acknowledgement, it will give the not acknowledged, which means that I requested 16 bit, you have transmitted that understanding. In order to give that understanding, the last read bit will have a NAC. Okay, then we will have the stop bit. Okay, you kindly understand this one. Last transmission of the read operation will be the NAC. Okay, so the start condition, slave address, then we will give read and write, then we will have ACK received, then we will transmit the data, and stop condition. So that's all about the first half of the I2C. In the next video, we will continue the same I2C in the next video, which will cover the clock stitchings arbitration topic. Thank you.